Hey guys, welcome back to the Workplace and Apprenticeship 20 videos. In this video, we're going to look at lesson 2 from chapter 3, which is talking about surface area of pyramids, cylinders, spheres, and cones. And before we jump into an example, we're first going to go over each of the different formulas that we have for surface area for each of the shapes listed. So just as a quick recap, surface area is the sum of the area of the faces of an object. So you need to look at that net. So if you guys have troubles working with net, make sure to go back to the previous video or see some of the other videos in this playlist to see how to draw the net. So the first object that we're going to look at is the square pyramid. So basically a pyramid has some sort of object on the bottom, so there's some sort of shape, and then all of the sides meet at one point. That's how you know it's a pyramid. And we'd say it's a square pyramid because the base is the shape of a square. So in order to find the surface area of a square pyramid, you have to look at the net and find the area of each of these faces. So you have 4 triangles and your 1 square. So the area of your base, assuming that we're talking about a square here, is your side squared, because that'd be, say, your side times your side, which would be side squared, plus the area of 4 of your triangles. So you take the area of your triangle and multiply it by 4. So in this case, because we're going to be multiplying 4 times 1/2, we can actually simplify this just to give you a bit of an easier formula. So then what we'd have is 2 times your base times your height. So here, your height of your triangle goes from the top of your triangle, goes down to the base, and those are the values that you'd be looking for. If you didn't have have the height of your triangle, you'd have to use the Pythagorean theorem. So that would be a squared plus b squared is equal to c squared. Okay? And then just be careful, because when you're using the Pythagorean theorem, you'd be dealing with a right triangle, but you're only dealing with half of that base. So be very careful with what value you're using to calculate that height. The next shape that we're talking about is a cylinder. So with the cylinder, if we were to look at the net, we have 1 rectangle and we have 2 circles. So you have to find the area of each and add them up. So if you look at the area of your rectangle, which is your length times your width, and the area of 2 of your circles, so you go pi r squared is the area of 1 circle, multiply it by 2 to get for 2 circles. Okay. The third shape that we're going to look at is a cone. So looking at that net, we have what looks like a partial, a part of a circle. And then we have a full smaller circle at the bottom, which would be that base of that cone. So here we're going to be looking at the area of that lateral surface, which would be this partial circle here. So that's your lateral surface, which you would find by taking your pi times your r times s. And your r is your radius. So you'd be looking at the radius of your small circle, or that base there. And then your S is your slant height, which would be this length right here. So we're looking at that slant height of your cone. And then to find the area of your circle, that is pi r squared. So once again, you're just looking at that radius. Moving on to our fourth shape here. Here we have a sphere. This one here has a super complicated net. But if you were to cut it out and then tape everything all together or glue it, you would find that we get what a sphere looks like. Okay? So looking at our formula here, there's really no easy way to put it other than just giving you the formula. So your surface area is equal to 4 pi r squared. So now let's move on to an example. And this one here is going to be number 2A from your notes. So Yoden is estimating the cost to reshingle her roof. To determine the number of shingles, she must calculate the area of the roof. The roof is shaped like a pyramid, with each side having a base length of 25 feet and a slant height of 15 feet 3 inches. So the question being asked here is, what is the total surface area that she needs to cover? So what we need to do here first is, it might help to draw a picture of what's going on. So here we're trying to reshingle her roof, and we know that the roof is shaped like a pyramid. Okay? So our first step here is we want to look at, maybe let's try drawing the net of a pyramid. So you want to start with the base. And then you want to draw each of those tips like you're unfolding it. So you're drawing each of those sides, which are in the shape of triangles, just like you'd be unfolding them. And then let's label what we know about this roof. So we know that each side has a base length of 25 feet. So each side of this roof has a length of 25 feet. And then we know that it has a slant height of 15 feet and 3 inches. And so when we're talking about, say, a roof, here we have say a pyramid roof. When we're talking about that, say that slant height, here we're talking about that height of that triangle. So talking about the length from the tip all the way down to the bottom of that roof or that side. So that means that that side right there is 15 feet and 3 inches. So looking here, we have the height of that triangle is 15 feet and 3 inches. So now that we have our diagram all labeled here, we have it fully drawn out, now we can actually look at calculating the surface area of that roof. And one thing that's really important here, that'll be a little bit different from the formula that I gave you. With a normal pyramid, you'd be looking at the surface area of that square base plus the 4 triangles, or the area of the 4 triangles. But in this case, when we're talking about shingling a roof, you don't want to shingle the bottom of that roof or what we consider the ceiling inside that house. That wouldn't make sense. It's not cost efficient. It would serve no purpose to shingle this little base here of that roof. So we're not actually going to calculate the area of that square base. So we're not actually going to look at the surface area of that square base. So really, we're going to look at adding up the area of each of those 4 triangles. Okay, so here we really have to look at the second part of that formula, which was 4 times 1/2 times your base times your height, or as we had simplified earlier, was 2 times your base times your height. So you don't want to talk about shingling the bottom or what would be inside your house. That is so inefficient and not great for costs. It serves no purpose whatsoever, so don't calculate it. So then we have to ask ourselves, well, do we know the base and the height of our triangles? And the answer to that is yes. We know that the base is 25 feet, and we know that the height is 15 feet and 3 inches. So one thing that we have to do that's really important first is that we have to make sure that we're dealing with the same units. So before we can start doing calculations, let's first convert this 3 inches into feet. You could convert the feet into inches, but that would require 2 calculations. So what we're going to do is we're going to calculate this 3 inches and move that into feet. So I'll just do this off to the side here. So step number 1 is to convert to feet. And so in order to convert to feet, what we're going to do is we're going to use unit analysis. So if you guys remember with unit analysis, you always start with what you're trying to convert. So here we're trying to convert 3 inches. And then you want to multiply it with the rate of what you know about, say, converting inches to feet. So here we're trying to get rid of inches, so put that in the bottom of your fraction. And we're trying to introduce feet, so put that up top. So then you have to go back to some of those conversion charts, or if you remember how many inches are in a foot. But we would know that there is 1 foot for every 12 inches. Okay? So if this makes your brain a little bit happier, write your 3 over 1, and then you're going to multiply across, just like you're multiplying 2 fractions. So 3 times 1 is 3, and 1 times 12 is 12. Put that into your calculators, or if you guys can see that right away. So 3 divided by 12 is just 0.25. And then what we need to do is, because it wasn't just 3 inches as its height of that triangle, or the slant height of that roof, then we have to add it with the original length, which if you guys remember up here, so it was 15 feet 3 inches. So then we have to go 15 feet plus that 3 inches, which was 0.25. And what we'd find is that height is 15.25 feet. Now we're working with the same units. Now we can go ahead and find the area or the surface area of that roof. So use your formula. You know that your surface area in this case is 2 times your base times your height. So you have 2 times the base, which you guys go up to your diagram, you know is 25, times your height, which we just calculated, was 15.25. Then if you put that into your calculator, you should find that the surface area of that roof is 762.5 feet squared. So don't forget your units. Here we're working with feet, and then the units for area and surface area are the units squared. Now that we've done all our calculations, don't forget that this here was a word problem, so we need to answer this with a sentence. So we could say that Jotun will need 762.5 feet squared of shingles to cover the roof. Once you guys have that all written down, then you guys have fully completed this question. If you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.